Hi everybody, I hope everybody's safe. I'm going to walk you through a little bit of section 6.3, and it's not a difficult lesson. It's actually more of what we have been doing. We did 6.4 first, before we did 6.3, so that you would be able to use the chain rule to find derivatives that they give you in 6.3. So we'll start by saying if y is equal to f of x, then the notations used for its derivatives are. Okay, so there's 4 ways that they can say find the derivative. The first 2 you're kind of familiar with. So f prime of x, that says find the derivative of f. The next one is y prime, you've seen that before. But now here's just 2 new ones thrown in, d over dx, dy over dx. All those 4 symbols just mean find the derivative of the function. And then here's the other new thing. When you have a derivative already, you can take the derivative of that derivative. And I always say math people are not creative, and this is another example. They call the derivative that we take first of the function the first derivative, and they call the derivative of the derivative the second derivative. So no fancy name for that second derivative. The notations used, there's 4 of them, and then they just adjust. So the first one is f double prime of x. That just says find the derivative of the derivative. Y double prime, find the derivative of the derivative. Then there's d squared y over dx squared. That's the same thing. And d over dx of dy over dx. So all those 4 symbols just mean find the derivative of the derivative. So here's our first example. And it's just find the derivative. Let's see if I can get a highlighter rather than a marker. There we go. Okay, so this here says find the derivative, and I notice that this is a quotient. So over here I put the quotient rule to remind me what I'm doing. So the first part of the quotient rule says I need to use g. So g down there is 4x minus 3, and I have to multiply that by the derivative of the top. So the derivative here of x squared would be 2x, and I put that here, and this becomes a 0, so I don't have to use that. Then there's a minus sign, and then f, so that's the top. So here I have the x squared plus 1 times the derivative of the bottom, and the derivative of this first term would be 4, and this would be 0, so I just have a 4 here. On the bottom, I take the 4x minus 3, and I just put a square on it. Okay, on the top here, I just distribute, so I get 8x squared minus 6x minus 4x squared minus 4. Keep the bottom as it is, and then I am just gathering up like terms for that last step where I get 4x squared minus 6x minus 4, and the bottom still remains 4x minus 3 all squared. So that's the first problem. This is the same thing. It is a quotient. So here's my quotient rule. And what they want is just the first derivative. So I take g, which is the bottom, 6 minus 5x, times the derivative of the top. So remember the derivative of a number, just a plain number, is always just 0. And then there's a minus sign here. And then the top, which is a 1. And then the derivative of the bottom. So this 6 would turn into a 0, and just because there's an x here, the derivative would be the sign and the number in the front, which would be a negative 5. On the bottom, I have the g minus 5x, and I put a square on it. The top, all this stuff here turns into a 0, and then negative 1 times negative 5 is my 5, and the bottom just remains as it is. Okay, this one says, hey, look at this. Take the second derivative. So I'm going to use the power rule to find the first derivative. So the first derivative would be 4 coming to the front, keeping the x as it is, reducing the power by 1 so it becomes a 3. 2 multiplies the negative 4, I get my negative 8 over here. Keep the x, reduce the 2 to a 1. And then a plain number turns out to be a 0, because remember that's it's 3x to the 0 power. So the derivative would be 0 times 3 times x to the negative 1, which would just be 0. So I always say just a number, then the derivative is 0. Okay, so that's the first derivative for x to the third minus 8x. Now, second derivative, easy as can be, easy peasy. You just take the derivative of the first term, so that would be 3 times 4 would be 12. Keep the x, reduce the 3 down to a 2. This is invisible 1 here, so 1 times negative 8 gives me a negative 8. Keep the x, and then x to the 0 power, which means x to 0 power is 1, so I don't have to write anything there. So the answer would be 12x squared minus 8. So that's the second derivative, so you can see how easy that is. This one uses the chain rule, so I want to take the first derivative of this. I notice that the inside is a function, and then it's raised to a 6th power, which is also a function. So this is a function of the function. That tells me it's a chain rule. Here's the official definition of how to do a chain rule, but remember I said it's pretty easy. You do it kind of like the power rule. 6 goes to the front, so here's there. Keep the parenthesis, reduce the power by 1, so that becomes a 5, and then multiply by the derivative of the inside. So 2 times 3 gives me a 6, x to the first power instead of 2, and then this is an x, so the derivative would be a negative 5. And this is my last one. It says find the derivative. It has obviously more steps here, so it's the grand finale problem. This is a quotient, so here's the quotient rule. So the quotient rule says take g first, so this whole thing on the bottom comes over here. The derivative of the top, so the derivative of x is a 1. Then there's a minus sign. Then the top, which is x. And then the derivative of the bottom, which I'm going to use the chain rule for because it's a function of a function. So to do that, the 3 comes to the front. I keep the parenthesis 4 minus x squared. I reduce the power of 3 down to a 2. And then I multiply by the derivative of the inside. So 4 would be 0, and then the other one would be negative 2x to the first. And then the bottom gets squared. So I just wrote the bottom and I put a square next to it, and I'll deal with that in the next step. Okay, so the next step, when I multiply by 1 here, that all just becomes the parenthesis to the third power. And then I left the negative x, and I multiplied 3 times the negative 2x to get this negative 6x. And then kept the parenthesis. And now on the bottom, I have a third power raised to a 2nd power, so that's why that becomes a 6th power. Okay, the front piece here I just left as it was. I multiplied negative x times negative 6x and got a positive 6x squared, but left the parenthesis just sitting there next to it, and kept the bottom as it is. And now, let's see if I can get a regular pen here. Whoops. Here's my pen. Okay, so notice that I have these parentheses to the 2nd power here, to the 3rd power here, to the 6th power here. So I'm going to take 2 away. I'm going to cancel 2. If I cancel 2, this becomes a 1, and this becomes a 4. So then I get my next step. Then in this next step here, all I did was rewrite it without the parenthesis. So 4 minus x squared plus 6x squared, and kept the bottom. And then the negative x squared and the 6x squared can become the 5x squared plus the 4, and then the stuff on the bottom. So that is lesson 6.3. I hope that this helps people who like to hear things rather than just look at things. If you have questions, remember, feel free to email me and I will email you back. If you can't type the question, then write it on a piece of paper, take a picture of it with your phone, somehow send that phone picture to me through an email, and I'll get back to you. So, okay, this one, okay, I don't know. Everything else is okay in my life. I'm quarantined to my little place here and doing fine, so I hope you are too. Bye.